Welcome to this special session that we put together for this conference, a session on the integration of network lighting systems with network building systems, in particular BACnet and DALI, with a couple of different points in mind. I'm Andy McMillan, I'm president of BACnet International, and my role here is to moderate a conversation amongst these three experts in BACnet and DALI and the integration of the two. So that's what I will try to do. There are a couple things we want to do with that. I'll start with just a 3-minute overview of BACnet, a 3-minute overview of DALI so you kind of understand the context. And then we'll jump into the conversation with our panelists, talking a little bit about, so what are the features and benefits of bringing them together? What are some of the challenges of bringing them together? And then there's a whole bunch of case studies we'll get into of examples of buildings that they've worked on or the companies they've worked on that have actually brought them together and done good things with that. So with that, let's go ahead and get underway. Let me introduce our panelists, Stuart Pajanski with DLC, the Digital Design Lights Consortium, and Luke Barr with Loitech Americas, and Michael Davidson with Synapse Wireless. So I'm going to let them introduce themselves for a minute in terms of their day job, then we'll bring them back to what their job is here on the panel.
Okay, I'm Michael Davidson. I'm a system architect for Synapse Wireless. We're a lighting controls company.
That was short and sweet. Yes. I'm Stuart Pajanski. I'm the technical director at the Design Lights Consortium. We are a nonprofit that focuses on energy and the environment, and our members are utilities across the United States.
Hello, everyone. My name is Luke Barr with Loitech Electronics. We're part of the Delta Group company. I get to wear a lot of hats over at that company, some support, some applications, some sales. We are hardware manufacturer, software developer of HVAC and lighting controls for building automation.
And in this session, they're all here to help us understand their experiences in pulling together network buildings and network lighting. So let me start with a quick BACnet overview. Those of you who have been in BACnet a while, you can take a brief nap. This will be 3 minutes of stuff you already know, right? But BACnet's sort of the foundation for interoperable building automation. It's an ANSI ISO standard, so it's global. And it's got multiple connectivity options, right? If you want to do twisted pair, you can do that. If you want IP, you can do that. If you want secure IP, you can do that. And it's all BACnet above that, so you don't have to concern yourself too much about it. And it's designed and applied in a broad cross-section of building applications. You know, building things like HVAC and access control and elevators, life safety and lighting and power management. It covers all those things and brings them together into an integrated platform. And it contains a comprehensive set of control and monitoring functionality. It's all the things you might want to do if you had all that data and control in a single platform. Right? Not just get at the data and share it, which you need for operating and maintenance, of course, and command and acknowledgement so you can control the thing the way you want to. But also sophisticated alarming and event management so you can get safe and reliable operation and optimize the building to do what you want it to do. And then things you just need to have in place, trending and logging, reporting, time synchronization, and things like that. We think about BACnet as the integration platform for intelligent buildings because it's the place where all the data can come together, and some of that data will come from BACnet subsystems, some will come from other subsystems that aren't BACnet but need the data to be integrated at the building level. And that DALI BACnet integration is an example of that, where the data needs to come together at an integration level. According to BizRIA, a market research firm that's been studying building automation for a few decades or so, 77% of projects globally specify BACnet, and over 90% here in the US. So that's why we've chosen that one to be our reference implementation example, if you will, for networked buildings. An important point is it's independently tested and certified, which is part of what makes it open and interoperable. And with that, I'll move on to a quick overview of DALI. So DALI is the digital addressable lighting interface, right? It's the foundation for networked lighting. And it's published and overseen by the Digital Illumination Interface Alliance. And it too has several different variants depending on what you're trying to do and how you want to go about it. Right, so it has a thing, DALI 2, which is a cabled solution, a DALI Plus, which is DALI 2 but wireless with more of a system focus, and D4i, which is DALI 2 capabilities but with broader mandatory requirements and a luminaire focus. And then it also is an international standard under IEC. And it's a modular standard. So there's pieces you can do and not do as you need for your application. So those are the elements of DALI. What it actually does, of course, is it connects things together that are relevant to lighting, right? Luminaires and switches and sensors and controllers. And if you appropriately specify and configure DALI, you can get out of it lighting control, of course, zones and groups and scenes and blink and all those fun things that lighting designers like to have. But also energy data, some diagnostics data, asset tracking, things that you can get out of a DALI system configured the way you need it to be configured. It also is independently tested and verified, providing the same kind of assurance of interoperability that BACnet does. For our purpose in this session, what we mean by DALI is a networked lighting solution that could be any one of those three or any combination of them, because for our purpose it doesn't matter too much. We're talking about networked lighting, networked building. Should they be connected? Well, that's not a question. Of course they should be connected. But what's the value of that, and what are the interesting challenges in doing it? So with that, I'm going to jump into asking our panelists here some questions that will hopefully lead to learning a few things about the value and the features involved in bringing those together. So I'm not going to direct questions at particular panelists unless maybe you give me a sad look and then I will. But in general, I'm just going to open the floor for a minute to talk about, so there are control algorithms that you can implement if you have networked lighting connected to networked buildings that you can't do with either one by themselves. So I'd like you to expound on some that you've seen that are valid because you have network lighting and building together. There's algorithms you can do that are useful for people. Go ahead.
Sure. I mean, combining the benefits that you can get from your lighting control system. You already have sensors in a space that are determining occupancy. You already have those same sensors could be also monitoring HVAC or for temperature and humidity that you can send to your HVAC. With those sensors, if you have some sort of people counting, whether it's tags or however you're counting those, if you have an accurate people count in a space, you can send that back, for example, to your HVAC system. ASHRAE 62.1, you can use that for your ventilation reset to determine minimum airflow in a space. So you can use the existing hardware that's already in your space for lighting control, use some of those data points, send it to your HVAC system, and integrate to become ASHRAE compliant and your system more energy efficient.
You're essentially then just reducing duplication in sensors is one opportunity.
Yeah. Mm-hmm. The same sensors being used for HVAC and lighting and counting and.
Okay.
One piece of hardware.
Other things?
Well, you could have a grocery store with coolers. You could use the sensors and the lights to let you know somebody's opened that cooler, so you're going to turn on the lights before it and after it. Also, you know how many times that door opened. So instead of having a mechanical switch, they're using a digital switch with the motion controllers. They said, okay, that opened 10 times. I need to crank up the AC, get this cooler cold, keep it cold. So there's lots of things like that. The lights on the outside of the building. Need to know, in a parking lot, you got motion sensors, you got time of day, you got schedules, you got to mix all that scenes together with a BMS system. And you can cookie cutter it from one operation to the next if you got a BMS system, combining all those points together.
Are there any obvious algorithms or things you might do if you had lighting connected to access control that you couldn't do without it?
With access control, you definitely can turn the lights on and off. I mean, the key is, if there's nobody there, why light it? So you got ASHRAE 90.1, you got Title 24 dictating that, hey, if nobody's here, let's not light this space. And I can remember 20 years ago, you could drive around a large city and you see a big office building and it's all lit up. You know there's nobody there, you can look in the windows, there's nobody there. So it's a way to save energy, but at the same time, access control, somebody comes in the door, you're gonna light up areas, you're gonna alert somebody that, hey, somebody's come in the building. So when you tie all that together, you don't have to have different systems sending alarms. And if you talk to any maintenance people, they got 6 different systems, they're getting alarms, they just ignore them after a while. They turn them off because they can't tell what's going on. All the systems are chirping versus if you got a BACnet system, it chirps once. Something's going on here. Somebody's come in. Nobody's scheduled to come in. Let's send somebody over to look at it.
Yeah, I'll add, Andy, that with the access control, what you can start doing though is, if you have VAV boxes and you know where somebody's going based on, it's a ID card to get into the building or whatever, it can light the path to where they have to go so you're not wasting the light, but it can also make sure it's getting the heating or the air conditioning at the right spot. So again, you're not wasting energy. But the biggest challenge is getting those systems to talk, because today the mechanical people don't talk to the electrical people, and so you've got the two systems that are getting installed very independently. And so it becomes the challenge of how do you do that? How do you get people to talk that don't necessarily talk within that building?
That makes sense to me. How about life safety tied to lighting? Does that help anything? Is there places you can use that?
Of course. College campuses, big use case. Around convention centers, you get, something goes late, areas around it will be lit up. Like for instance, Detroit Convention Center, big time. If you walk in a little area, all the lights come on. So even shopping centers with Title 24, if nobody's around, you got to turn those lights down to 30%. But if somebody gets in the area, you got to turn 4 or 5 lights up to 100%. So big time safety. Lighting makes people feel safe.
So room control typically connects a bunch of things across systems. How would room control take advantage of the fact you have HVAC and lighting all tied together?
One of the solutions that we provide is year shade progression. So we can put in your latitude, longitude, your the azimuth, your altitude for the sun, and we can track that sun throughout the year. And so we know if you have like a high rise, at this point in the day, the sun is shining right into my room. And so I could close shades, and that can help with prevent radiation for the heating. The sun's going to be heating up the room if it's just pounding right inside. So you close the shades. You can keep the temperature down more naturally. You can also use the shades from the based on the position of the sun. You can open up the shades, let in more light, or you can close them, and then you have to turn on the lights more. So as you integrate your system, you can use it to, you're monitoring, you're I guess, using the position of the sun to help with HVAC and lighting from that, and shade control.
Yeah, at the room level, there's a ton of opportunity, because if you think about many times in an office building, there are rooms that are not used, especially post-pandemic. Right? There's a lot of buildings that have vacancy half the time, right? Staff's working from home or whatever. So at that room control level, it allows you to put the lighting or the HVAC systems that are operating on at the right time for the right spot. And I was in a session yesterday, I guess, and the person says, in this room, there's probably 50 different sensors between the lighting, the humidity, the temperature, well, when you get into a smaller room, do you need all those sensors when you start looking at the cost per room? So how can you maximize the energy savings in that room, or just the energy use in that room, at the same time as minimizing the cost associated with that? And that's where you can start looking at the room controls, Andy, at a sensor level and how all that information is shared.
Good, thank you. Outside of control algorithms, right, within the building and tying things together, are there other benefits to the owner-operator of having lighting and HVAC tied together in terms of the building establishment, the commissioning, the operations, things like that?
Yeah, so when you think about within your facility, there are less and less people that are knowledgeable in the systems. So if you've got a building where you've got, multiple systems because it's been retrofitted over time and things like that, and now you've got different protocols going on and you have to know this one and that one. If you can get down into common protocols, common systems, so DALI being an open protocol, BACnet being an open protocol. Those open protocols by themselves are great, but it's the fact that you've got open systems that allow all of this to come together that enable a facility, the facility manager or whoever, contractor, to not have to know multiple things that are going on in that building if they can focus in on just one in particular. So I can give a quick lighting example. Boston University, their campus is located in downtown Boston area, and they have acquired buildings over time. And in building 1, it had a lighting control system from manufacturer X. Building 2, manufacturer Y. And they wound up with 9 different buildings and 9 different lighting control systems. And that staff then had to be knowledgeable in every one of those systems. Now, if they just had one system, if it was a DALI-based system, then all they had to do, it was a standard, and they just had to deal with the one. So you take the same thing with BACnet, right? And I'm sure they had, systems from Train and JCI and you name it, right? And if it wasn't all on BACnet, then they've got to know all those. So this allows them to really narrow it down to utilizing the resources in such a way that makes sense.